Okay, this is stoichiometry 1. This is dealing with what we call mole ratios. So the first step in a stoichiometry problem, where you're dealing with the given as being in moles and you're trying to find moles, is that you have to make sure you have a balanced equation. So in this equation where nitrogen reacts with oxygen to form dinitrogen tetroxide, we have to go through and make sure it's balanced. 2 nitrogens, 2 nitrogens, 2 oxygens, 4 oxygens. I have to go ahead and put a 2 there. So the new mole ratio, or the mole ratio that balances the equation in the reduced form, is 1 mole of nitrogen for every 2 moles of oxygen to give you 1 mole of nitrogen, dinitrogen tetroxide. Now, the problem is going to be if we have 6 moles of oxygen, how many moles of dinitrogen tetroxide do we need? So this is a typical mole-to-mole stoichiometry problem in that we're trying to find how much product given a certain amount of a reactant. So I'm going to start off and say 6 moles of oxygen are used. Now, to determine how much product of dinitrogen tetroxide I have to go ahead and apply this mole ratio. But I'm starting in moles, so what I have to do, doing a factor label approach, is I'm going to put moles of oxygen on the bottom and put what I'm looking for, moles of nitrogen, dinitrogen tetroxide, on the top. Well, this mole ratio happens to be 1 mole for every 2 moles of oxygen. I get those numbers from the balanced equation right here. And so, because these are all in moles, my moles of oxygen. This is stoichiometry 2. What we're going to do is the same problem that we did in stoichiometry 1. However, this time we're going to go one more additional step. And instead of being given 6 moles of oxygen and determining how many moles of dinitrogen tetroxide we have, we're going to go ahead and determine how many grams of dinitrogen tetroxide we have. So in this second problem, we're going to be given 6 moles of oxygen, and we need to find the mass of dinitrogen tetroxide that we have. So believe it or not, we go through the same steps. I'm going to go ahead and rewrite the equation and make sure that it's balanced. And in this problem, what we're going to find is here we still have the 6 moles of oxygen, and we're finding grams. So the plan, what I'm going to call the stoichiometry molar roadmap, is that we have to go moles of oxygen, and still what we did in the last problem is get to moles of dinitrogen tetroxide. But then in the final step, we're going to change that to grams of dinitrogen tetroxide. So this is what we call kind of the heart of the reaction, or the heart of the stoichiometry, where we look at the mole ratio using the balanced equation. And then a mole to gram conversion would be multiplying by the molar mass. So I consider that kind of 3 steps. It's really 2 separate steps. So let's go ahead and write that out. Move the paper up. We take 6 moles of oxygen. I'm going to repeat kind of what we did above. Get rid of my moles of oxygen and start talking about the new substance that I want, which is dinitrogen tetroxide. And in order to go from one substance to another, I need to use the balanced equation. So in other words, I need to get it in the unit of the mole, which is from the balanced equation. So I'm going to look at what this mole ratio is. It's 1 to 2. So I'm going to put a 1 up here and a 2 on the bottom. So I know my moles of oxygen cancel, and I'm left at this point, if I took 6 divided by 2, I'm left with moles of dinitrogen tetroxide. So the last step is going to say 1 mole of dinitrogen tetroxide is so many grams. That's my molar mass. So to figure out the molar mass of dinitrogen tetroxide, I take 2 nitrogens, 4 oxygens. Each nitrogen is 14. Each oxygen is 16. This happens to end up to be 28. 16 times 4 is 64. I add those up. Carry the 1. That's 92 grams. So in the end, I'm going to multiply 6 times 92 divided out by 2. And I get 276 grams for my final answer. So if I start with 6 moles of oxygen, I'm going to produce 3 moles, but those 3 moles are actually 276 grams. Now, I have to say I'm not paying attention to any sig figs because technically in this problem we only had 1. So I'm just using this as an example. So really our answer would have been 300 if we did pay attention with sig figs. That would be the correct answer since I just started with 1 sig fig in the initial problem. So that is a stoichiometry problem going from moles to grams.